All right, babies, welcome to our first video lesson for Unit 2. In this unit, we're going to focus primarily on what is called an exponential function. This is going to be quite different than what we did last unit on linear functions. So an exponential function is going to be just a very simple non-linear function that's going to look very similar to a linear function in its form, but it's going to look quite different when we look at it in terms of what the values look like in points, tables, graphs, etc. So a exponential function is just simply a nonlinear function that's always going to be of the form a times b to the x. So this is the basic way, a standard way in which an exponential function is going to be shown. Just like all functions, we always have our inputs and our outputs. So you'll notice here I have my input x and my output y. So that's going to be true for any function that we have. What makes a function exponential in this case is I want you to notice where x is. Notice that my input x is written as an exponent, or as a power, if you will, okay? So what this is saying is we're taking two values, we have a and b, and instead of multiplying that by x, which we would do in a linear function, my input is going to be the exponent. And I'll talk about what this means in a second. Okay, but we're going to have two values written in this function, and they're going to have what's called the a value, which is going to be the initial value where we start, and then our b value is going to be a multiplier. So to give you an example, let's say that I had an exponential function written in the form y equals 1 times 2 to the x. Okay? What this means is I'm going to take the number 1 and I'm going to multiply it by 2, and what the exponent represents is the exponent's going to tell me how many times I'm going to multiply 1 by 2. So let's take, for example, let's say that x is equal to, let me just choose number 3. So let's say x is equal to 3. When you have an exponent, say 2 to the third power, what exponents represent is how many times I'm going to multiply this base number, the base number being a 2, how many times I'm going to multiply that 2 by itself. So 2 to the third power literally means 2 times 2 times 2. So in an exponential function, when I plug in the 3 right here, what it means is I'm going to take this initial value of 1, and I'm going to multiply it by 2 3 times. Okay? So it's 1 times 2 times 2. So my multiplier is going to be this value of 2, but then I'm doing that 3 times, and that's where that exponent comes in. So what we're doing is we're taking some initial value, and we're either multiplying it, or what we're also going to see is that there's division, and I'll talk about that in our next example. But what we're doing is we're changing that initial value by multiplication or division, which is different than a linear function, okay? Now, there are some restrictions here. So when we look at that initial value, a, that initial value can be anything. I can essentially start from anywhere I want, okay? But the multiplier is going to decide how the exponential function looks like, and there are some restrictions to this. Our multiplier b cannot be equal to 1. So let's say that, for example, I switch. In my example, I had there a and b. So let's say that instead of 1 times 2 to the x, let's say I had 2 times 1 to the x. That would mean I'd start at 2. That would be my initial value. But now what I'm going to do is I'm going to multiply by 1 as many times as I want. Now, let's say I were to multiply by 1 3 times. Why b cannot be 1 is because if I were to keep taking 2 and multiplying it by 1, 2 is never going to change. No matter how many times I multiply it by 1, I'm always going to get the number 2. So the first important detail is that b cannot be equal to 1. Also, b has to be greater than 0. So what this means is that b cannot be negative. So to give you a quick example here, let's say now that I take that example I had here where my initial value is 2. So again, I'm starting at 2, but now I'm going to multiply by negative values. So say I take negative 1 times negative 1 and so on and so on. What happens when my multiplier is negative is this. If I start off with my first two values, 2 times negative 1. Notice my a value is a positive 2. When I multiply it by negative 1, that's going to give me a negative 2. So notice my sign switched from positive to negative. But then when I multiply it by the second negative 1, when I multiply two negatives, what I'm going to get is a positive. So what ends up happening here is that when I multiply by negative numbers, I start off as a positive, I then went to a negative, I then go back to a positive. And if I were to continue this pattern, it would switch between positive, negative, positive, negative, positive, negative. And that's not representative of an exponential function. So two things here is that my b value has to be a number other than 1, but it also has to be a number that's going to be in the positive realm, and it cannot be negative. All right, so our first example is going to look at how do we recognize an exponential function first through a table. So an exponential function is going to be different than linear. So when we saw linear functions, we looked at adding and subtracting. Exponential functions are going to be similar but different. So what we're going to look for is that instead of adding, we're going to first view multiplication, okay? So we're going to be multiplying by a value. But sometimes we might see the values, instead of always going up, we might see division as well, okay? So we're going to look for multiplication or division by the same number every time. So in A, notice my x values were going up by 1 every time. It goes 0 to 1 to 2 to 3. If I look at my y values, notice I have a pattern. It goes 2, 4, 6, 8. So what I want to do is look at, is this exponential? So when I look at the values of y, notice from 2 to 4, in order to get from 2 to 4, I'd have to add 2. And then from 4 to 6, add 2, and then add 2. So notice here that I'm adding 2 every time. So an exponential function is not going to be shown through addition or subtraction. Instead, it's going to be shown through multiplication or division. So in this case for A, this one is going to be not exponential. It's going to be some other function. Okay. In B, notice I have the same increasing values of x, but now when I look at the y values, I see 4 to 8, 8 to 16, and 16 to 32. So if I think of addition here, it'd be plus 4, and then plus 8, and then plus 16 between the values. So notice that I'm adding a different amount every time. This is something that we briefly touched on last unit, but now that I see since the values are different, that means the rule of addition is not working here. It's got to be something else. So this is where exponential functions come in, because in order to get from 4 to 8, instead of adding 4, I could also multiply by 2. From 8 to 16, I can also multiply that by 2. And from 16 to 32, that's also multiplication by 2. So notice here that I'm multiplying by 2 every single time. So in this case, this would be exponential. So exponential functions, we're going to look for multiplication, or the opposite of that, which could be division. All right, kind of going into that then, my next example down here, I have my x values from -2 going up to 1. You'll see my y values will go 14, 11, 8, and 5. So kind of like the opposite of A, instead of adding values, you'll see here that we are subtracting 3 every single time. But because we are subtracting, this would not be exponential. Instead, when we look at D, however, instead of subtracting, okay, let's say now that I'm dividing. Ooh, take 27, divide it by 3, I get 9. 9 divided by 3 would get 3. 3 divided by 3 would get 1. Notice there I'm dividing by 3 every single time. So in this case, it's going to be exponential. So an exponential function is going to show the values either increasing or decreasing by multiplication or division. All right, in this example, we're going to look at just identifying a and b from the function itself. So again, all exponential functions are going to be of the same form. Y equals a times b to the x. So we have two values written in here, a, which is my initial value, and then we're going to have b, which is my multiplier. So in this case, I have the function, my first one, y equals 4 times 2 to the x. So just based on how it's written, my a value would be the first number, 4. And then my b value is going to be the value in parentheses, and that's going to be 2. We always recognize the multiplier because the multiplier is the thing that's being risen to the x power. Also know that these two terms are separate. This value of x as an exponent does not apply to the 4. It only applies to the value inside the parentheses. Okay? For this one, we have 20 times 1/2 to the x. So here, my a value is 20, and my b value is 1/2. All right, in this example, we're going to talk about is how to evaluate an exponential function. So to evaluate, it's the same thing we did with a linear function. Think of it as inputs and outputs. What I'm going to do is I'm going to take my given value of x, in this case is x equals 3, and all I'm going to do is I'm going to plug it in where x goes. So I'm going to take 3, plug it in right here. So what this is going to look like is I'm going to have -2 with my initial value, my multiplier is 5, and now I'm plugging 3 in where my x is. Now the key thing here is that my x is now an exponent. So this is written as negative 2 times 5 to the third. As an exponent, this 3 applies only to the 5. So if I were to separate this out, it's negative 2 times 5 to the third power. What that means is it's going to take negative 2 and it's going to multiply it by 5 3 separate times. That's what the exponential function represents. And that's going to give you an output of negative 250. Okay? So we're plugging in a number where x goes, but now x is an exponent, so it's going to represent how many times I'm multiplying by that value, which is representative b. Okay, same thing here. Notice I have 3 times 0.5 to the x. You'll notice that this is not a big number, but a small number. But same kind of principle here. I'm going to take my value of x, and I'm going to plug that in as my input. So then I would have my function 3 times 0.5, and then my exponent is going to be a negative 2. Now in this case, notice I'm plugging in a negative number. That is okay. I can plug in any number where x is. That's my input. The only thing I talked about early on is that my b value cannot be negative. Okay? But if I were to plug in this negative 2 in where x goes, so what that means is I'm going to take that value of 3, which is my initial value. Now, notice that I have 0.5 to the negative second power. So this is the sassy part, folks. When I plug in negative exponents, how that is different from this example where I had positive exponents is that when I plug in negative exponents, I'm not going to multiply by 5 or whatever the value is multiple times, but instead when I see a negative exponent, instead I'm going to divide. So in this case, what this means is I'm going to take that number 3 and I'm going to divide it by 0.5, not once, but twice. So negative exponents, you can think of that just like division. So if I were to evaluate that then, what you're going to get is a value of 12. So my input was negative 2, my output would be a positive 12. All right, so this is evaluating exponential functions. All right, I want you guys to pause the video here. I want you to try examples C and D on your own. What does it look like here to evaluate the given functions for those inputs? Go ahead, pause the video, give that a shot. All right, first example here, negative 3 times 2 to the fourth means I'm multiplying negative 3 by 2 4 times, so I would get negative 48. Notice here my a value is negative. That is okay. Again, my a value, my input code, those can be negative. My b value cannot. And it's the second example. I plugged in negative 3, so 4 times 0.25 to the negative third power. Again, this represents multiplication, but because my input is a negative, it actually means that I'm dividing again by 0.253 times, which would give me a value of 256. So this was just practice on evaluating the function. All right, now let's apply this to actually a real-life problem. So here I have a graph that represents the bacterial population after a certain number of days. So on the graph you have it starting at 0 days, okay, it goes all the way up to 7 days, and then this is the population of that bacteria. Notice the graph here. So again, why is this exponential? So you'll notice that the graph is not a straight line. You'll see here this exponential function is being represented by a curve. Looking at the spacing between the dots, you'll notice the spacing is closer together, and you'll see that starting, once we get past 2, you'll see the spacing of the dots gets further apart. And that is a result of multiplication in this case. So this first example just wants us to write an exponential function. So exponential functions, again, are all going to be of the form y equals a times b to the x. So if I give you something like this and I want you to write the exponential function, think about a as our initial value. So when I look at my points that are shown here, my initial point is right here, okay, which is a value of 0, 3. So on 0 days, I have 3 units of bacteria, let's say. So that means my initial value in this case is going to be 3. And what I'm going to do then is I'm going to figure out what is my multiplier. In parentheses, what's the multiplier? So when I look at from day to day, I go from 0 to 1 to 2 to 3 and to 4. Notice that the bacteria start off at 3, then they go up to 12, then to 48, 192, and 768. So what I want to do is try and find the multiplier. Quick, simple way to find the multiplier is take the first two numbers, 3 and 12. And what I can do is find the multipliers. I'm going to take the second number, 12, divide it by the first number, 3, and I would get the value of 4, which means that from day to day, it's getting 4 times bigger. So my multiplier in this case is going to be the number 4. And then I would just write my input of x and my output of y. So this would be my exponential function, 3 times 4 to the x. Now the next question says, find the population after 5 days. So notice my graph stops at 4 days. So what would be next? Well, we could follow the pattern, again, of multiplying by 4 every single time. But now that I know my function, y equals 3, and then we have our multiplier, which is 4, and now instead of x, I can plug in my input of 5. And it's like saying, okay, I'm going to start at the number 3, and I'm going to multiply by 4, not once, not twice, not 3 times, but all the way up to 5 times. And that's going to tell me then my bacteria population, which would be 3,072 as my output. All right, quick little application there of what we've been talking about. All right, now, we just got done talking about linear functions, so just to kind of do a quick comparison. Linear functions are going to be any functions that when you graph it form a line. We did look at standard form and slope-intercept form, so here would be an example of slope-intercept form. The key thing here is that the slope m represents how much the line is going up and over, represents what's called the slope, okay? That is compared to exponential functions, which again in equation form look different, and in graph form you'll see that instead of being a line, they start to bend upward, they start to curve. Okay, so there's a big difference between the two. However, there are some similarities in what they look like and how we recognize these things. Okay, in these last two examples, we're just going to compare linear functions and exponential. So linear functions, what we're going to look at is, are we adding or subtracting? And exponential functions are going to be multiplication or division. That's going to be the big difference. So what we're going to do is look at the values that we see in our table. So x, again, is going to be the inputs, which could be anything. We're plugging those values in. What we're specifically going to look at are my y values. So I have 9, 5, 1, -3, and -7. And I want to try and figure out what's going on between those values. So from 9 to 5, how would I get from 9 to 5? In this case, this would be subtracting 4. From 5 down to 1 would also be subtracting 4. And if I follow that pattern, you'll notice it's subtracting 4 every single time. So because I'm subtracting 4, this would make this a linear function. Now my next example, I have here my x values going from -3 up to 1. My y values starting from 1/3 and going up. A little bit tough. I know you have yourself a fraction here, so if we just start from the second one, all right, 1 to 3, notice that I'm adding 2. 3 to 9, I'm adding 6. 9 to 27, I'm adding a bunch, so notice that it's not addition, but instead, to get from 1 to 3, I can multiply by 3. 3 to 9, I can also multiply by 3. 9 to 27, also multiply by 3. So since I'm multiplying by a common number, this would be an exponential function. So linear functions, we're adding, subtracting. Exponential function, we are multiplying or potentially dividing. And lastly, let's again look at what it looks like as a graph. So we're going to plot these points. So let's start off in A. We have the points 0, 1, all the way up to -4, 7. And let's plot those points and see what it looks like. You should notice once plotting those points, by its shape, you can see that it's going to form a line. Forming a line because in this case it's going down by a constant amount every single time. In this case it's going down 3 every single time. Versus this next set of points. You'll notice when plotting those, it's also going downward, but you'll see if I ever start to connect the dots, how it starts to bend towards the end. So in this case, because it's bending, this would be an exponential function versus my very first example was a linear function. So key thing here we looked at was exponential functions, but I also wanted to draw some differences between linear functions since we spent a unit looking at that. If you guys got any questions, make sure you jot those down. We'll see you next time.